For pretty much all of human history, our idea of time was, well, simple. It was like a river, right? Just flowing forward, always at the same speed for everyone, everywhere. But in the 20th century, that feeling, that intuition we all have was completely shattered by one single stubborn fact, and it kicked off one of the biggest revolutions in the history of science. Everything in our gut, our common sense, just screams yes, of course it is. But as we're about to find out, the actual laws of physics, they paint a much, much stranger and more flexible picture of reality. So let's get into it. Okay, to really get why the new idea was such a huge deal, we have to start with the old one. For centuries, the world basically ran on Isaac Newton's clock. It was a universe where everything was certain, absolute. This is actually a super old debate. On one side, you've got Aristotle. He thought time was just a way to measure change. If nothing ever changed, time wouldn't even exist. But on the other side, Newton argued that time was this absolute thing, like a rigid box that exists all on its own, whether anything happens inside it or not. And for over 200 years, Newton's view completely defined how we saw the universe. This idea, right here, led to the concept of a master clock for the entire universe. In Newton's world, that clock ticked at the exact same rate for you, for me, and for some alien in a galaxy billions of light years away. It was universal, it was unstoppable. So what this does is it turns the whole universe into this giant, predictable machine. I mean, in theory, if you could just know the position and speed of every single particle, you could calculate the entire future and the entire past. Everything was basically set in stone. But then, a crack started to show in this perfect clockwork universe. A single fact from experiments that just didn't make any sense. And it all revolved around one thing: the speed of light. So picture this. Bart's on a ridiculously fast skateboard, and he's chasing a beam of light. Now, common sense and Newton's physics would tell us that if he's going almost as fast as the light, it should only look like it's pulling away from him really slowly, right? You just subtract his speed from the light speed. Simple. Make sense? Yeah, but that's not what happens. Not at all. In reality, experiments have proven over and over again that no matter how fast you are going, you will always measure that beam of light zooming away from you at its full, incredible speed. It's almost like the light doesn't even know you're chasing it. So this number, it's the ultimate cosmic speed limit. It is an absolute. And this one little fact was totally impossible to explain with Newton's universal clock. See, if space and time are the same for everyone, this result just can't be true. Physics had a major, major problem on its hands. And the person who figured it out was, of course, a young patent clerk named Albert Einstein. He had this incredible insight. He realized the problem wasn't the speed of light. The problem was our ancient, deeply ingrained ideas about space and time themselves. Einstein's radical idea was that space and time, they aren't separate things at all. They're actually woven together into a single, flexible, four-dimensional fabric. He called it space-time. And this fabric can stretch and it can shrink. And this is what solves that crazy light speed puzzle. If the speed of light has to stay the same for everybody, then something else has to be flexible. And that something is time. The faster you rocket through space, the slower you travel through time. This effect has a name you've probably heard of. It's called time dilation. A clock on a spaceship flying near the speed of light would literally tick slower than a clock back here on Earth. You can see this is a total, fundamental shift in how we see reality. For Newton, space and time were just this rigid, unchanging stage where the play of the universe happened. For Einstein, the stage itself, space-time, is a dynamic actor in the cosmic drama. Time is no longer universal, it's personal. Okay, so stick with me because this is where things get really weird. If everyone's clock ticks at a different rate depending on how they're moving, what on earth does that do to our idea of now? Well, it completely shatters it. Imagine a duel happening on a moving train. For the referee who's on the train, the light from two guns firing at the same time reaches them at the same moment. To them, it's a fair duel. But for a referee standing on the station platform watching this train fly by, well, the train is moving towards the light from one gunshot and away from the other. So to them, the shots did not happen at the same time. So who's actually right? Einstein's shocking answer is they both are. So this whole idea, the relativity of simultaneity, it's not just some weird brain teaser. It has some really profound, kind of mind-bending philosophical consequences for how we understand reality itself. I mean, think about what this really means. If we can't even agree on what's happening right now across a distance, then the entire idea of a single universal now that we all share, it's an illusion. My now is different from your now, and both are different from the now of somebody in the Andromeda galaxy. So, physicists have a way of thinking about this. They call it the block universe, or sometimes, kind of playfully, the space-time loaf. The idea is that all of time, every single moment that has ever happened and ever will happen, already exists. The past, the present, and the future, they're all just different slices in this four-dimensional block. This is a really powerful way to picture it. Our gut feeling that time flows like a river, that's the illusion. According to this view of physics, reality is a lot more like a frozen river. Every moment is fixed, eternally stuck in its specific coordinate in space-time. And look, this isn't just some fringe theory. Einstein himself came to this conclusion, and even he found it deeply unsettling. But he saw it as the logical, inescapable consequence of his own theories. All right, so what does all this abstract physics mean for you and me? Because this isn't just about galaxies and spaceships. It touches the very core of our existence and how we perceive reality. I mean, really let this sink in. If this block universe idea is correct, then your life isn't a story that unfolds one moment at a time. It's more like a complete, unchanging object that exists all at once in four dimensions. The moment you were born, the moment you ate breakfast this morning, and the moment you're hearing my voice right now, they're all equally real, forever. And that leaves us with this ultimate dilemma, right? On one hand, we have the cold, hard laws of physics that describe a timeless, static reality. And on the other hand, we have our most fundamental human experience, that powerful feeling of time passing, of a future that's unwritten and a past that's gone forever. So which one is more real? The universe as physics describes it, or the universe as we experience it? That's a question that, frankly, physics may never be able to answer.